The Amazon has a reputation. The Darien has a body count. The world's most dangerous jungle is not the one you think it is. It is 60 miles wide. 60 miles, about 100 kilometers, of terrain on the border of Panama and Colombia that has broken empires, swallowed armies, and killed people at a rate that makes the Amazon look forgiving. The Amazon is 2.7 million square miles of rainforest. The Darien is 60 miles, and the data on deaths per mile of crossing, on disease density, on the concentration of everything capable of ending a human life in a confined space, consistently places the Darien above it. Size is not what makes a place dangerous. In 2023, over 520,000 people attempted to cross the Darien on foot. 1 in 5 of them were children. The officially recorded deaths were 141. Researchers say the real number is likely many times higher because the jungle consumes evidence before anyone can count it. Bodies lost in river floods are not recovered. People who die after exiting are not recorded. The true toll is unknown. It may never be known, but the people crossing it today are not the first to learn what this place does to human plans. In 1698, Scotland sent over 1,000 colonists to the Darien to build a trade empire connecting the Atlantic and Pacific Oceans. The jungle killed the majority of them within 2 years. Across multiple expeditions, more than 2,000 people died. The financial loss erased a quarter of all liquid capital in Scotland, a catastrophe so complete it pushed an entire nation into political union with its neighbor. The United Kingdom exists, in part because of what this jungle did to those colonists. Before that, the Spanish, who had already conquered the Aztec and Inca empires, established the first permanent European settlement on the American mainland inside the Darien in 1510. They abandoned it. The most powerful empire of the 16th century could not hold 60 miles of ground. And the strangest part of this place has nothing to do with what lives in it. The ground the Darien sits on was once open ocean. 3 million years ago, it rose from the seafloor, and when it did, it separated two oceans, redirected the warm currents of the Atlantic northward, created the Gulf Stream, and triggered the Ice Age cycles that shaped the course of human evolution. A 60-mile strip of land changed the climate of an entire hemisphere. 1/5 of its plant species exist nowhere else on Earth. The first formal archaeological survey of the region did not begin until 2019. Scientists report finding previously unknown species on every expedition into the interior. This is not a place science has finished with. It is a place science has barely started, and it is still, today, doing what it has always done to everything that tries to cross it. Subscribe if stories like this are what bring you here, and drop a comment telling me something. Are you watching this to wind down, or did the title pull you in and now you need to know everything? Let's go in. The Darién Gap occupies the easternmost reaches of Panama, pressed against Colombia, where the continental landmass narrows into a difficult corridor. Its exact dimensions depend on where its boundaries are drawn, but the region stretches roughly 60 to 100 miles from edge to edge and covers about 6,500 square miles. Within that area, several landscapes meet at once. Tropical rainforest gives way to mangrove wetlands, mountain ridges descend toward river valleys, and coastal waterways thread through terrain that changes from 1 mile to the next. Much of this region belongs to Darién Province, the largest province in Panama. At its center lies Darién National Park, covering about 579,000 hectares. It is the largest protected area in Central America and the Caribbean, and in 1981 it was designated a World Heritage Site by the United Nations Educational, Scientific, and Cultural Organization. Its importance comes from the unusual range of habitats contained within one connected landscape, from coastal ecosystems to highland forest, allowing species with very different requirements to exist within the same protected region. The region also sits between two major bodies of water, with the Caribbean influence reaching from the north and the Pacific shaping the southern side. This position gives the Darien a geography where ocean, mountain, river, and forest interact within a remarkably compressed space. The shape of the land becomes more pronounced as the forest rises inland. Mountain systems associated with the Andes approach the Pacific coast here, producing ridges separated by narrow ravines and river valleys. A route that looks direct on a map can become a succession of climbs, descents, crossings, and detours once it reaches the ground. Water is part of the geography at every level, with rivers cutting through the mountains and lowlands before reaching the coast. The landscape, therefore, has no single surface. It is a layered arrangement of slopes, channels, wetlands, and forest. Human geography is woven into this terrain as well. The Embera, Wunan, and Guna have long-standing connections to the region, with communities whose knowledge of rivers, plants, seasons, and animal movements developed through generations of living within these environments. Their languages and traditions carry distinctions that reflect different relationships with the land and waterways. The persistence of these communities also places the modern map in a longer human history, one that reaches far beyond the colonial expeditions that later gave the region its reputation. The word gap describes something built for human movement rather than something missing from the landscape itself. The Darien Gap is the unfished section of the Pan American Highway, the enormous road network that extends through much of the Americas. There is no continuous highway across the interior here. Roads approach the region from either direction and then stop, leaving the forest, rivers, and mountains between them. That absence has shaped the Darien in a very physical way. Without a major road crossing the interior, infrastructure has remained limited, and the landscape retains connections that roads elsewhere have divided. The gap therefore appears on maps as a break in transportation, while on the ground it forms a continuous meeting place of land, water, climate, and life. Its present geography is only the surface of the story. The ground beneath these forests carries a much older history, one that begins with a seaway where the Darien stands today. 20 million years ago, the place now called the Darien was covered by seawater. North and South America were separated by a marine passage known as the Central American Seaway, a broad connection between the Pacific and Atlantic Oceans. Warm equatorial water moved through that opening, carrying heat from one side of the planet to another. The landscape familiar today had not yet begun to rise. Far below the waves, the machinery of its creation was already operating. The Pacific Plate was moving toward the Caribbean Plate, forcing oceanic crust downward in a process called subduction. As one plate descended, pressure and heat helped generate magma, feeding volcanic activity along the developing Central American arc. Volcanoes appeared on the seafloor, some eventually growing into islands that broke the surface. Each eruption added another piece to a landscape that would take millions of years to become recognizable. Between those volcanic islands, sediments accumulated from nearby continental margins and from the erosion of the new land itself. Layer by layer, mud, sand, volcanic material, and fragments of older rock gathered in the shallow spaces. Islands became linked by deposits. Channels became narrower. The ocean passage that had once allowed water to travel freely between two great basins was gradually being transformed into a chain of landforms. The process was uneven. Some sections rose while others remained submerged, and earthquakes repeatedly reshaped the developing terrain. The boundary between land and sea moved back and forth across geological time. Eventually, around 3 million years ago, the remaining marine connection closed. The Isthmus of Panama had formed, joining the two American continents and dividing the Pacific from the Atlantic. The Darien occupies one of the most rugged portions of that young land bridge. Here, tectonic forces created steep relief, fractured rock, and mountain systems that rise abruptly from lowland forests. Cerro Tacarcuna reaches about 6,065 feet above sea level, a modest height compared with the world's highest mountains, yet significant within this compressed tropical landscape. Its slopes rise directly from the surrounding lowlands, making the change in elevation especially pronounced. The age of the surrounding rock also matters. Much of the terrain belongs to a relatively young geological setting, shaped by processes that have continued long after the first islands emerged. Earthquakes remain part of that setting. Faults and plate boundaries continue to accommodate movement beneath the region, while erosion works continuously against the uplift created by tectonic forces, reshaping the surface as the deeper crust continues to move. Rain enters cracks, loosens slopes, carries sediment into rivers, and reshapes channels. A ridge can be raised by geological forces over immense spans of time, then gradually carved into ravines by water. This gives the Darien an unusual physical character. Its difficult slopes, fractured ridges, unstable riverbanks, and steep valleys are connected to the same geological history that created the land itself. The forest grew across terrain that was assembled piece by piece from volcanic activity, sediment uplift, and erosion. Every river valley records movement. Every exposed rock surface carries part of the history of an ocean that once occupied the space. The Darien therefore begins far deeper than its trees. Its present form is the surface expression of a collision between moving plates, continuing beneath a living ecosystem that occupies ground still shaped by geological change. For millions of years, warm water moved through the opening between the Americas, carrying tropical heat from the Pacific toward the Atlantic and back again. Then, the passage disappeared. Around 3 million years ago, the rising land of the Isthmus of Panama interrupted that exchange, and a change in geography became a change in planetary circulation. The new land bridge forced tropical Atlantic water into a different route. Instead of continuing westward through the seaway, warm water accumulated in the Caribbean and moved northward along the eastern side of North America. That flow became part of the Gulf Stream system, carrying enormous quantities of heat toward the North Atlantic. The current still travels from the Caribbean along the eastern coast of North America and across the ocean toward Europe. Heat carried northward by the ocean does more than warm the water itself. It changes the atmosphere above it. Warmer seas release more moisture into the air, and winds carry some of that moisture toward higher northern latitudes. Over the Arctic, precipitation can fall as snow. When enough snow survives each summer, layer after layer accumulates, eventually forming large ice sheets. The timing of this transformation matters. Around the same broad period, the northern hemisphere entered a pattern of recurring glacial and warmer intervals that has continued for roughly 2.7 million years. The exact relationship between the formation of the isthmus and the growth of northern ice sheets remains an active scientific subject, with changes in atmospheric carbon dioxide, ocean circulation, orbital cycles, and other processes contributing to the climate system. The new land bridge became one important part of that larger planetary arrangement. The ocean itself also changed. Before the seaway closed, Pacific water could enter the Atlantic directly across the tropics. Afterward, the Atlantic developed a different balance of salt and fresh water. Greater evaporation in the subtropical Atlantic, combined with altered freshwater input and circulation, changed the density of seawater. Denser water can sink, helping drive the large system of deep and surface currents, known as the Atlantic Meridional Overturning Circulation. Those movements connect distant regions. Water warmed in the tropics can influence conditions thousands of miles away. Deep water formed in northern seas can eventually travel through the global ocean before returning toward lower latitudes. The circulation is slow compared with the movement of air, yet its reach extends across entire ocean basins. The glaciers that later shaped landscapes around the northern hemisphere therefore belong to a much larger story. Ice carved valleys and lakes, transported enormous quantities of sediment, altered coastlines, and changed habitats repeatedly as the planet moved between colder and warmer phases. Human evolution unfolded during this unstable climate rhythm, with changing environments influencing where forests expanded, where grasslands appeared, and where animals could live. The Darien occupies only a small portion of the land bridge that separated two oceans, yet its geological formation became part of a chain reaching from tropical rivers to Arctic ice. A landscape, assembled through tectonic movement, altered the path of seawater, the distribution of heat, the chemistry of the Atlantic, and the rhythm of Earth's climate. The forest above that geology belongs to the same transformation. Once the two continents became connected, animals and plants gained access to environments that had been separated for millions of years, and the living world began its own continental exchange. Imagine North America and South America as two libraries that spent millions of years writing different books of life. Their animals evolved apart, shaped by separate climates, predators, diseases, and food webs. Then the land between them rose from the sea, and the two libraries suddenly gained a doorway. For tens of millions of years, South America remained isolated from the northern continents. Its forests and plains supported creatures that belonged to a distinct evolutionary history. Giant ground sloths browsed through ancient vegetation, some reaching the mass of elephants. Glyptodonts carried heavy armored shells over their bodies, while terror birds stood more than 3 meters tall, which is about 10 feet, and hunted across open ground. Toxodonts, bulky plant eaters with a rhinoceros-like build, occupied another branch of that extraordinary southern fauna. North America had followed its own path. Horses and camels evolved there long before modern descendants appeared elsewhere. Mammoths and mastodons moved across northern landscapes, while early relatives of wolves and saber-toothed cats occupied predator niches. These animals had spent millions of years responding to one another without encountering the communities developing south of the tropical barrier. The new connection changed that separation. As the Isthmus of Panama emerged, animals gained a continuous terrestrial route between the continents. The exchange became especially pronounced around 2.7 million years ago, when species began moving through Central America in both directions. Armadillos, opossums, and ancestors of capybaras expanded northward. Horses, tapirs, and early big cats traveled southward into environments where their lineages had never existed before. The movement was uneven, shaped by climate and habitat. A species accustomed to grassland could spread along suitable corridors, while another, adapted to dense forest, might find the route broken by unfamiliar conditions. The new land bridge therefore became a filter as well as a passage. Animals that could tolerate changing temperatures, food sources, predators, and terrain had better opportunities to continue. Others stopped at ecological boundaries or disappeared from the advancing populations. The Darien occupied a special position within this exchange. Its combination of mountains, rivers, wetlands, and forest created one of the most complicated portions of the route between the continents. Species moving through Central America encountered a landscape that could redirect their movements toward different valleys and coastal plains. Each successful expansion carried more than an animal into new territory. It carried an entire lineage, along with parasites, prey relationships, competitors, and ecological habits developed on the opposite continent. This process became known as the Great American Biotic Interchange. Its legacy remains visible in living forests today. The jaguar belongs to a lineage with northern origins that expanded into South America. Armadillos, whose evolutionary history began in South America, now live far to the north. Opossums spread in the opposite direction as well, becoming familiar members of North American ecosystems. The Darien is where these histories meet within the same connected landscape. A bird from a southern lineage can occupy a forest shared with mammals, descended from northern arrivals. Predators, herbivores, insects, and plants carry traces of movements that began millions of years ago. What appears today as one tropical ecosystem is partly the meeting ground of two continental histories, joined by a strip of land that transformed separation into exchange, leaving living descendants of both worlds throughout the forest today. At first, the rain seems like part of the scenery. Then it becomes the landscape itself. In the Darien, water arrives with such regularity and volume that the boundary between weather and environment begins to disappear. The region lies close to the equator, where strong sunlight supplies energy throughout the year. Average daily temperatures remain high, while moisture moves constantly between ocean, forest, soil, and atmosphere. Rainfall gives this climate its defining character. Core areas of the Darien receive more than 118 inches of rain in a year, while some interior locations receive over 177 inches. The Amazon basin varies greatly from place to place, commonly receiving around 60 to 100 inches annually. In the wettest parts of the Darien, a year's rainfall can therefore approach twice the upper amounts found across much of the Amazon. The difference becomes clearer when the calendar changes. The principal rainy season generally extends from late April through December, covering about 8 months. During the wettest periods, rain can arrive on most days, sometimes returning several times within the same afternoon. May and October often bring especially heavy rainfall as moist air from surrounding seas meets the rising terrain. Even the months considered relatively dry retain substantial precipitation. From January through mid-April, monthly rainfall can still reach roughly 6 to 8 inches. The forest receives enough moisture during these months to keep rivers, soil, and vegetation active. There is no long interval in which the landscape fully dries. Instead, rainfall shifts between greater and lesser intensity, leaving the ground prepared to receive each new storm. The mountains help create this persistent supply. Moist air approaching from the Pacific encounters rising slopes, cools as it climbs, and releases water as rain. Air arriving from the Caribbean contributes another source of moisture. When these air masses meet the complex ridges of the Darien, clouds can build against the terrain rather than dispersing quickly. The mountains therefore influence both where rain falls and how long wet conditions persist. Water changes the physical shape of the region from day to day. A river crossing that appears manageable during a period of lighter rainfall can become impossible after storms arrive upstream. A channel may deepen, accelerate, widen, or develop a new route through gravel and sediment. Rain falling many miles away can become the controlling event for someone standing beside a river hours later. This relationship between distant storms and local water is especially important in mountainous terrain. Heavy precipitation runs downhill through narrow valleys, collecting volume as smaller streams join larger channels. The forest may hide the storm from anyone below the canopy, while the river carries its effects outward. Floodwater can transport branches, stones, and loose soil, altering banks and leaving fresh deposits along the channel. The same water that sustains the Darién's exceptional biological richness also determines how people move through it. Soil becomes saturated, slopes become heavier, and paths can lose their shape. Vegetation grows rapidly where moisture remains available, while rivers repeatedly redraw portions of the terrain. The climate is therefore more than a backdrop to the forest. It is one of the forces continually constructing the conditions in which every living thing must exist. Each storm adds another small adjustment to that living terrain, leaving water, soil, and vegetation in continual exchange. The first threat arrives without announcing itself. A mosquito lands, feeds for a few seconds, and leaves behind an infection that may take days to reveal its presence. In the Darién, malaria transmission is established, with Plasmodium vivax responsible for most reported cases in Panama and Plasmodium falciparum also present. The warm, wet environment provides breeding conditions for mosquitoes through much of the year, while standing water remains scattered across the forest after rainfall. Malaria is only one part of the biological burden. Dengue circulates through mosquito populations as well, carried by insects that can live around human activity and reproduce wherever small collections of water remain. Preventive medicines used against malaria do not provide equivalent protection against dengue. A person can enter the forest prepared for one infection while remaining exposed to another carried by a different mosquito. Then there are the sandflies. Leishmaniasis is caused by microscopic parasites transmitted through their bites, with several forms affecting humans. Cutaneous infection can produce ulcers and lasting scars on the skin. Mucosal disease can damage tissues around the nose and mouth, while visceral leishmaniasis attacks internal organs and can become fatal without treatment. These illnesses develop according to biological cycles involving insects, wildlife hosts, vegetation, and human movement, creating a web of transmission that does not depend on any single species. Chagas disease adds another layer. Triatomine insects can transmit the parasite responsible for American trypanosomiasis when infected material from the insect enters broken skin or sensitive tissues. Early infection may produce few recognizable symptoms, allowing the parasite to remain unnoticed. Years later, chronic disease can damage the heart and digestive system. The timescale is different from malaria, yet the forest carries both possibilities within the same broad environment. What makes the Darién unusual is the concentration of these pathways within a limited corridor. The Amazon contains an extraordinary burden of infectious organisms, yet its enormous geography allows populations, settlements, waterways, and medical services to be distributed across millions of square miles. The Darién compresses exposure into a much smaller landscape where a traveler may encounter mosquitoes, sandflies, contaminated water, and insects associated with several diseases during one journey. The biological setting is also connected to the movement of people between continents. Mosquitoes and other vectors belong to populations shaped by different ecological histories on either side of the land bridge. Pathogens move through animal reservoirs and human communities, while travelers themselves can carry infections across geographic boundaries. The forest, therefore, becomes part of a larger network linking wildlife, insects, people, and microorganisms. Medical care adds another dimension to the risk. The interior has no dense network of hospitals or paved roads connecting every valley. Reaching treatment can depend on rivers, foot travel, weather, and access to transport from remote locations. During periods of heavy rain, those connections become harder to maintain. A disease that might be manageable with timely diagnosis in a city can become far more consequential when diagnosis itself requires leaving the forest, and uncertainty follows every delay. In the Darien, the pathogen layer has no visible boundary. It occupies the same air, water, vegetation, soil, and living communities as everything else. The forest does not need to contain the greatest number of diseases on Earth. It only needs several effective transmission routes operating together, with distance separating exposure from treatment. A snake can be present for hours without being noticed, occupying the same patch of ground that people use as a path. In the Darien, the fer-de-lance is one of the most consequential examples. This pit viper is widely distributed across tropical, Central, and South America, and its venom can cause severe swelling, tissue damage, bleeding, and dangerous disturbances of blood clotting. Its reputation comes partly from how well it blends into the forest floor, where mottled scales disappear among leaves, roots, and fallen branches. The animal is built for close-range encounters. Fer-de-lance vipers hunt rodents, frogs, lizards, and other small animals along the ground, using heat-sensing pits to detect prey in dim conditions. They can remain motionless while vegetation moves around them, then strike when something enters the appropriate distance. A person moving through dense vegetation may therefore approach a snake without ever seeing its outline clearly, even while following a familiar-looking trail. Other venomous snakes share the same ecosystem. Several species of pit vipers occupy different habitats, from lowland forest to wetter mountain environments. Their presence reflects the abundance of prey and shelter available throughout the Darien. Roots create cavities, fallen timber provides cover, and layers of leaves offer places where small animals gather. The forest floor contains countless spaces suitable for an ambush predator only a few feet long. Water introduces another kind of animal. American crocodiles inhabit rivers, coastal lagoons, and estuaries across the region. They can remain almost completely concealed at the edge of the water, with only portions of the head visible above the surface. Their presence matters because rivers are among the most natural routes through rugged, tropical terrain, placing people and crocodiles in the same narrow spaces. Plants add their own physical hazards. The chunga palm is armed with stiff spines that can catch clothing or pierce exposed skin. A small injury becomes more significant in a warm, moisture-rich environment where microbes are abundant and wounds can remain wet. A cut or puncture can become contaminated with soil, plant material, or microorganisms before there is any opportunity to clean it properly. The forest floor also changes the way hazards are perceived. Dense vegetation limits the distance across which a person can inspect the ground. Leaves overlap roots, branches, stones, and shallow depressions, creating a surface with few reliable visual markers. A snake can occupy one section while a thorn catches a boot several steps later, and unstable ground can follow immediately after. This produces a distinctive kind of biological exposure. The danger does not come from one dominant predator occupying every path. It comes from several forms of life, sharing the same narrow layer, each adapted to a different opportunity. A viper waits for prey. A crocodile watches a river margin. A palm protects its growing tissues with spines. Fungi and bacteria occupy soil and plant matter, participating in decomposition and nutrient cycling. For a person moving through the forest, these organisms become part of one continuous physical environment. Sight reaches only a short distance, footing changes constantly, and every contact with vegetation or water carries its own set of possibilities. The forest floor is therefore more than a surface beneath the canopy. It is a densely occupied biological layer where animals, plants, fungi, and microbes operate within inches of one another. In the closing years of the 17th century, Scotland was an independent kingdom facing serious financial strain. Merchants and investors gathered around an ambitious venture called the Company of Scotland, trading to Africa and the Indies. Its grandest project was a colony on the Caribbean coast of the Darien, intended to create a commercial gateway between the Atlantic and Pacific Oceans. The location seemed almost perfectly chosen on a map. The new settlement, named New Caledonia, would stand near the narrow land bridge connecting two enormous trading worlds. Ships could arrive from the Atlantic, goods could cross the isthmus by land, and another fleet could carry them onward toward the Pacific. For Scotland, the scheme promised access to international commerce without depending entirely on larger European powers. In 1698, 5 ships carried roughly 2,500 settlers toward the Darien. They reached the coast and began building a settlement at a place called Caledonia Bay. Wooden structures rose along the shore, while supplies were unloaded and plans for trade were put into motion. The first vision of the colony belonged to an era when maps could make difficult landscapes appear deceptively manageable. The surrounding environment soon imposed a different rhythm. The settlers had entered a landscape whose climate, ecology, and disease burden were almost entirely unfamiliar to them. Their plans depended on sustained labor, regular supplies, and healthy workers, yet each of those foundations proved fragile under tropical conditions. Tropical diseases spread through the settlement, including malaria, dysentery, and yellow fever. Food was difficult to produce reliably, while unfamiliar crops, poor soil in some areas, and shortages of essential supplies placed additional pressure on the community. Fresh provisions from Scotland required a long Atlantic voyage, making every delay more costly. Spanish authorities regarded the settlement as an intrusion into territory claimed by Spain. Spanish forces and nearby colonial settlements placed further pressure on the struggling colony, while the Company of Scotland lacked the resources needed to maintain a prolonged confrontation. Reinforcements and supplies became increasingly difficult to secure, leaving the settlers caught between disease, hunger, isolation, and geopolitical resistance. A second expedition reached the Darien in 1699, yet the combined colony could not recover. By 1700, the settlement had been abandoned. Only a fraction of the original settlers survived, and many of those who remained were weakened by illness and deprivation. The Company of Scotland had lost much of its investment, while the wider Scottish economy had absorbed a financial shock of extraordinary scale. Estimates suggest that the Darien venture consumed a substantial share of Scotland's available capital, with some historians placing the loss near a quarter of the nation's liquid wealth. The disaster deepened pressure for political and economic reform. In 1707, Scotland and England entered the Acts of Union, creating the Kingdom of Great Britain. Historians continue to debate how much weight the Darien failure carried in that decision, alongside trade restrictions, political calculation, succession concerns, and financial pressures. What remains striking is the scale of the chain connecting a remote tropical settlement to European history. An investment scheme crossed an ocean, entered a difficult landscape, collapsed under disease and scarcity, and left Scotland facing consequences far beyond the colony itself. The Darien had become part of a political story whose effects reached far beyond the forest and across the shape of Britain. In 1510, on the western shore of the Gulf of Urabá, Spanish settlers founded Santa Maria la Antigua del Darien, one of the earliest permanent European settlements on the mainland of the Americas. The location placed them at the edge of a region that promised access to rivers, gold, and routes toward both oceans. From the settlement, Spanish ambitions reached far beyond its wooden buildings and narrow clearings. The surrounding waterways offered routes into the interior, while the coastline connected the colony with Spanish shipping networks. Its most famous resident was Vasco Núñez de Balboa, a figure whose name became inseparable from the geography around him. In 1513, he led an expedition across the isthmus and reached the Pacific Ocean, becoming the first European known to have seen it from the Americas. The journey revealed something the settlement had already suggested. The Darien could connect two enormous maritime worlds, yet the land between them demanded extraordinary effort to cross. Spanish power gave the colony soldiers, ships, administrators, and access to wealth from nearby territories. Gold from the Cana River region became an important attraction, drawing attention toward mineral deposits farther inland. For a time, Santa Maria appeared capable of becoming a lasting center of Spanish expansion. Its position offered strategic value, while the surrounding rivers opened routes into a landscape that Europeans had barely begun to understand. The forest imposed limits that military strength could not easily remove. Tropical diseases spread through the settlement, while unfamiliar food systems and difficult transportation weakened its population. The indigenous communities of the region also defended their territories and resisted Spanish demands for labor and tribute. Their resistance was part of a wider struggle across the isthmus, where alliances, warfare, and local knowledge repeatedly complicated colonial expansion. Balboa himself was eventually removed from power and executed in 1519 after a political struggle with Spanish authorities. Santa Maria's importance declined soon afterward. By 1524, the remaining settlers had abandoned the town, leaving behind structures that the surrounding environment gradually absorbed. Pedro Arias Davila, the governor who had replaced Balboa, had already established a new settlement on the Pacific side. Panama City became the stronger colonial center, while the earlier town faded from maps and memory. Archaeology has since returned to the abandoned site, revealing traces of streets, houses, religious buildings, and objects left behind by its inhabitants. Excavations have helped identify the settlement's layout and reconstruct parts of daily life, including the material remains of cooking, trade, worship, and defense. The discoveries also preserve a rare record of an early colonial experiment that lasted only a small number of years. Layers of soil and vegetation now cover much of what once served as a colonial town. The Spanish Empire would soon control enormous territories in the Americas, defeating the Aztec Empire in 1521 and the Inca Empire in 1532. Its armies could topple powerful states and command immense resources. Santa Maria tells a more complicated story. A settlement backed by one of the world's strongest imperial systems could survive only briefly in the Darien, where disease, geography, and indigenous resistance worked together to limit expansion. The town disappeared, while the landscape that surrounded it remained. The rivers of the Darien carry more than water. For the Emberá and Wunan, they have long served as routes, calendars, food sources, and guides through a landscape whose patterns become legible through repeated experience. Villages are often connected by waterways, and movement by canoe allows people to work with the terrain instead of forcing roads across it. Seasonal changes in river levels, rainfall, fish behavior, and forest plants form part of knowledge passed between generations. That knowledge extends into the materials used for everyday life. Homes may be raised above the ground, helping families adapt to flooding and wet conditions. Forest plants provide foods, fibers, dyes, medicines, and construction materials, while familiarity with particular locations helps communities recognize which resources can be gathered at different times of year. Such knowledge is practical, accumulated through observation and memory, then refined through use. The Embera name refers to a family of related languages and communities rather than one completely uniform speech system. Across their territories, language carries names for plants, animals, waterways, and places, preserving distinctions that may have little meaning outside the forest. Wunan communities maintain their own language and cultural traditions as well. To an outside map, a river can appear as a single line. To people who live beside it, that same river can contain recognizable sections, each associated with particular seasons, resources, routes, and histories. In 1983, Panama formally recognized the Embera Wunan Comarca, an autonomous territory covering 4,180 square kilometers, which is about 1,614 square miles, across river basins in the Darién. This recognition reflected a much longer presence. The communities had already developed social systems adapted to the region long before modern administrative boundaries were drawn. The Guna followed a different historical path. Their communities maintained strong independence and resisted Spanish expansion through generations of conflict. During the 18th century, Guna groups sometimes formed alliances with pirates and other enemies of Spanish authority, using those relationships to oppose colonial control. Resistance also included refusal of forced labor and defense of territory. Later migrations carried many Guna communities toward the Caribbean coast, where they established settlements that became centers of Guna political and cultural life. Their histories reveal something important about survival in the Darién. Familiarity with the environment can matter more than speed, strength, or machinery. A community that understands when rivers rise, where food can be gathered, which plants are useful, and how movement changes with the seasons is working with information accumulated across generations. The distinction reaches deeper than practical knowledge. Colonial expeditions generally arrived with an outside plan and expected the landscape to accommodate it. Embera, Wunan, and Guna communities developed within the landscape itself, shaping homes, travel, food systems, and social life around conditions that outsiders often treated as obstacles. Their continued presence is part of the Darién's human geography, a record of adaptation measured across centuries rather than expeditions. Their survival also carries a different meaning from the survival of a traveler passing through. A traveler can depend on equipment, supplies, and outside assistance. A community must remain through repeated floods, changing seasons, political pressure, and generations of environmental change. The Darién offers no permanent certainty, so knowledge becomes a form of continuity. River levels, useful plants, fishing places, and familiar routes become remembered details, carried forward through families and communities as carefully as any physical possession. High above the forest floor, the Darién becomes a different landscape, shaped by branches, wind, fruit, and the movement of animals through layers of foliage. Here, one of the forest's most formidable hunters moves through a world that can remain almost entirely separate from the ground. The harpy eagle belongs to this upper realm, where enormous strength is matched by precise control. A mature harpy eagle can carry a powerful body through dense vegetation with a wingspan approaching 2 meters, which is about 7 feet. Its legs end in massive talons that can reach roughly 13 centimeters, which is about 5 inches. Those talons are built for gripping arboreal prey, allowing the eagle to seize monkeys and sloths among branches where a larger bird would struggle to maneuver. Its broad wings and relatively short tail give it the agility needed to weave between trunks and limbs. The Darién has become one of the most important remaining refuges for harpy eagles in Panama. Fewer than 450 are estimated to remain in the country. Their disappearance from many other regions follows the loss and fragmentation of mature forest, since a breeding pair requires a large territory and depends on tall trees for nesting. A single pair may range across as much as 65 square kilometers, which is about 25 square miles, while raising young. Their presence, therefore, reflects more than the survival of one species. It indicates that enough connected forest remains to support a demanding predator. At 30 meters above the ground, which is about 98 feet, the canopy can resemble a second landscape suspended over the first. Sunlight reaches leaves at different angles, branches form pathways, and fruiting trees become gathering places for animals that may spend most of their lives above the soil. Down below, the forest floor follows another rhythm. The two layers occupy the same coordinates, yet their inhabitants can pass months or years without meeting. The aerial community is arranged vertically. Ornate hawk eagles and crested eagles occupy parts of the same broad realm, while other birds specialize in particular heights, hunting styles, and prey. Parrots cross openings in groups. Toucans move between fruiting trees. Sloths remain among branches, where their camouflage blends with leaves and moss. Every level carries its own routes and feeding opportunities, turning the canopy into a three-dimensional network. During heavy rain, the foliage becomes a living roof. Water strikes the upper leaves first, divides among branches, and descends in countless smaller streams before reaching the soil. The dense cover also changes how sunlight travels downward, while trunks and leaves interfere with signals used by navigation devices. A person standing below may see only fragments of the sky through gaps between crowns. For the harpy eagle, this layered architecture is home, hunting ground, and territory. Its survival depends upon the continuity of the trees themselves. Old emergent trees provide nesting platforms high above competing animals, while connected crowns allow adults to travel between feeding areas without descending into the dense vegetation. The architecture of the forest, therefore, becomes part of the eagle's life cycle, shaping where it hunts, rests, breeds, and raises its young. When the canopy remains connected, the upper world retains its pathways, nesting sites, prey, and shelter, preserving a habitat that exists several stories above the earth, while another ecosystem unfolds directly below. The ground beneath the canopy carries its own chain of command, shaped by animals that rarely need to climb into the upper world. Among them is the jaguar, a predator whose body is built for moving through tangled forest, river margins, and rocky slopes. It is the largest cat in the Americas, and its hunting method is unusually precise. A jaguar can deliver a powerful bite through the skull of prey, piercing bone with force that allows it to kill animals that would be difficult for other cats to handle. Its short, muscular jaw, and broad head give it an ability that has become one of its defining adaptations. Across the Darien, a jaguar may travel through several kinds of habitat during the course of its life. Forest edges near rivers offer access to fish, turtles, and mammals. Deeper woodland provides peccaries, deer, monkeys, and other prey. The animal's territory can cover dozens of square miles, depending on prey availability and habitat quality. Such a range requires uninterrupted movement between feeding areas, resting places, and water. A fragmented forest can therefore become a series of isolated pieces, each too small to support the same ecological role. Tracks along muddy banks, claw marks on fallen trunks, and paths through dense vegetation reveal how much of this territory is connected by movement rather than by any visible boundary. The forest functions as a continuous hunting ground because its many habitats remain joined. That continuity matters beyond one animal. The Darien forms a vital link in the Mesoamerican jaguar corridor, connecting populations across Central and South America. Jaguars, from distant regions, remain part of a broader breeding network when forest pathways stay connected. Genetic exchange can then continue between populations, helping maintain diversity across generations. When barriers divide those populations, opportunities for mating decline, and smaller groups become more vulnerable to disease, reproductive difficulties, and environmental change. The jaguar shares this terrestrial world with other hunters. Ocelots move through dense vegetation after smaller mammals and birds. Pumas occupy a broader range of habitats and can adapt to conditions that exclude more specialized predators. Their presence adds another layer to the food web, with several carnivores dividing prey according to body size, hunting strategy, habitat, and timing. The same forest can therefore support different predators without every encounter becoming direct competition. Along the rivers, American crocodiles add another dimension. They occupy estuaries, lagoons, and stretches of fresh water, wading near places where animals approach the water. Their presence becomes especially significant because rivers form natural routes through the Darien, while also creating obstacles for anyone attempting to cross the forest. Water levels can change rapidly after rainfall upstream, altering banks, channels, and usable crossings. A river can shift from passageway to barrier within the same journey, bringing a large aquatic predator into an already complicated landscape. Together, these hunters form a layered hierarchy. The harpy eagle governs portions of the canopy, while the jaguar commands sections of the ground. Ocelots, pumas, and crocodiles occupy different positions around them, each shaped by particular prey and habitats. Their coexistence reflects an ecosystem assembled from many evolutionary histories, concentrated within connected forest. 3 million years of interchange brought lineages from two continents into overlapping ranges, and the Darien became a place where those histories continue to meet through living predators, prey, rivers, trees, and the paths between them. A species count can look like a number on a page until the forest is imagined as a collection of separate lives, each occupying its own narrow place. In the Choco and Darien region, scientists have documented more than 8,000 plant species, with some estimates rising above 10,000 when species still awaiting formal description are considered. Roughly one-fifth of these plants are endemic, meaning their natural distribution exists nowhere else on Earth. The bird community gives the numbers another scale. Between 600 and 670 bird species have been recorded across the Darien. The continental United States an area roughly 400 times larger, has around 900 recorded bird species. That comparison places an unusual concentration into perspective. A region comparable in area to Connecticut can hold a bird community approaching two-thirds of the total recorded across an enormous continent. Among those birds are around 60 species found nowhere else within the world. These are full species with their own evolutionary histories, breeding populations, feeding habits, and ecological roles. Their geographic range ends with this forest. If the habitat disappears, there is no distant population waiting in another landscape to replace it. Each species, therefore, represents a lineage tied to a particular combination of rainfall, elevation, vegetation, food, and seasonal conditions. Mammals add another layer, with about 168 species documented in the region. Reptiles number around 97, while amphibians reach a similar count. Then comes the larger biological world that is much harder to measure. Insects, spiders, worms, fungi, microscopic organisms, and countless other forms of life continue to resist complete cataloging. Every fallen branch, patch of soil, stream margin, and flowering plant can support organisms that occupy only a tiny ecological niche. Part of this richness begins with geography. The land bridge brought North American and South American lineages into contact, placing two enormous evolutionary histories within the same region. That created a broader starting inventory of mammals, birds, reptiles, plants, and other organisms. The Darién then added its own layers of separation. Mountains divide valleys, rivers isolate slopes. Changes in elevation alter temperature and vegetation. Wetlands, coastal forests, upland forests, and river corridors provide different conditions within relatively short distances. Those divisions give populations opportunities to become specialized. A plant adapted to one slope may encounter different soils a short distance away. A frog restricted to a particular stream system can gradually follow its own evolutionary path. Birds may separate according to feeding heights, nesting sites, or forest structure. The result is a biological mosaic in which neighboring habitats can contain different communities while remaining connected within the same larger forest. The same richness that fills field guides also increases the number of possible encounters. More species create more predators, prey, parasites, competitors, venomous animals, disease vectors, and microbial relationships. Each interaction adds another thread to the ecological fabric. In the Darién, biodiversity and difficulty belong to the same physical story. Rainfall sustains vegetation, vegetation supports herbivores, herbivores sustain predators, and standing water supports organisms that carry disease. The species count is therefore more than a measure of abundance. It is a record of how many different forms of life can be sustained by one landscape and how closely their survival remains tied to the conditions that created it. Medicine can begin with something as ordinary as a leaf. In the Darién, thousands of plant species carry chemical defenses shaped through long biological competition, yet much of that chemistry has never been examined in a laboratory. More than 8,000 plant species have been documented across the wider region, and many produce compounds whose properties remain unknown. Each unfamiliar plant represents a collection of molecules that may interact with cells, microbes, parasites, or inflammation in ways science has never tested. The history of medicine offers reasons to pay attention. Quinine, one of the earliest effective treatments for malaria, came from the bark of the cinchona tree, a South American tropical plant. Salicylate compounds from plants helped inspire aspirin. Paclitaxel, a powerful cancer medicine, was developed from a compound first isolated from the Pacific yew tree. These discoveries did not begin with laboratories inventing unfamiliar chemistry. They began with organisms that had already spent millions of years producing molecules for their own survival. The Darién contains a different library, shaped by its own geography. Plants growing in saturated soils face one set of pressures. Those climbing toward the canopy encounter another. Epiphytes, palms, vines, shrubs, and trees interact with insects, fungi, herbivores, and neighboring plants, each relationship creating opportunities for chemical adaptation. Some compounds discourage feeding, others inhibit competing organisms or protect tissues from infection. A substance created for one purpose in the forest may eventually prove useful for an entirely different purpose in medicine. There is also another kind of library here, carried in human memory. Embera and Wunan communities have developed detailed knowledge of medicinal plants through generations of direct contact with their surroundings. The identity of a useful plant, the part selected, the season for gathering it, and the preparation method can form a chain of information transmitted through families and communities. Such knowledge provides clues that laboratory surveys alone cannot easily produce. That knowledge, however, is vulnerable to interruption. Younger generations increasingly move between traditional communities and urban society, changing the circumstances in which plant knowledge is learned and practiced. When a knowledgeable elder dies without passing on a particular use, an observation accumulated through generations can disappear with that person. Scientific documentation has captured only a portion of this living record. Modern research faces a physical limitation as well. Much botanical sampling occurs where researchers can reach relatively easily, including river corridors, roads, settlements, and protected areas with established access. Deeper forest receives far less attention because reaching it requires time, equipment, trained guides, and careful movement through difficult terrain. The places that are hardest to enter can also contain populations that have experienced less disturbance and may include plants with highly localized distributions. This creates an unusual race between discovery and loss. A plant does not need to be famous to contain valuable chemistry, and a useful compound does not announce itself through appearance. Its significance may remain locked inside tissue until someone collects it, studies it, and understands its biological activity. If a species disappears before that process begins, the opportunity disappears with it. The Darién therefore holds more than biological diversity. It holds a body of chemical knowledge assembled by evolution, much of which humanity has barely begun to read, understand, test, preserve, or translate into knowledge that could someday serve human health. In 2019, a different kind of expedition entered the Darién. Researchers began Darién Profundo, a systematic archaeological project involving the University of California, Berkeley, and Panamanian academic institutions. Its importance came from how little had been done before it. The province contained evidence of human occupation stretching back thousands of years, yet much of its interior had never received sustained archaeological investigation. Even deciding where to look required working with indigenous communities whose knowledge of the landscape could guide the search. The first discoveries began to loosen assumptions that had survived for centuries. Spanish records from the 16th century preserved 23 words attributed to what colonial writers called the Cueva language. For generations, those fragments could be treated as a small window into a single community. Linguistic analysis produced a more complicated picture. The words belong to several language families, including Guna, Wunan, and Arawak, with additional connections to languages of the Caribbean. A handful of words, therefore, carried an unexpected history. The people encountered by Spanish expeditions were not one population gathered around one language. The region contained several communities with different linguistic identities, relationships, and traditions. Their connections extended beyond the immediate forest. Evidence of exchange linked communities in the Darién with places reaching toward South America and the Caribbean, suggesting a human landscape shaped by movement and contact long before European settlement. Canoe travel appears to have helped people and ideas move across distances that the forest made difficult to cross on foot. Archaeology added another layer. Early work associated with the survey identified traces of settlement and resource use in interior areas that had received little previous attention. Such evidence matters because written colonial accounts naturally recorded the places and people Europeans encountered most directly. A settlement deep within difficult terrain could remain absent from those documents while still being part of a much older network of habitation. Pottery, food remains, stone tools, altered soils, and other traces can preserve fragments of that older landscape after names and memories have changed. The significance of the project reaches beyond a revised map of human history. Archaeology depends on traces that survive after generations have passed, including soils altered by occupation, fragments of objects, remains of structures, and patterns in the landscape. Each trace can preserve information that written records never carried. In a region where documentation was already sparse, even the first systematic examination could therefore change the scale and character of what was known. That pattern has a broader scientific meaning. The Darién had remained beside centuries of European exploration, colonial administration, biological collecting, and modern scientific research. While much of its interior continued to receive limited direct study, archaeologists were finding that the human record contained more complexity than expected. Biology, ecology, and chemistry face a similar frontier where incomplete sampling can make a place appear less complicated simply because fewer people have looked closely. The discovery was therefore larger than any single artifact or vocabulary list. A landscape, long treated as difficult terrain, was beginning to reveal a record of human movement, exchange, and adaptation that had been waiting outside the written archive. The first systematic survey did not complete the story. It changed the boundary of what could be known, showing that even after centuries of attention around the edges, the interior still held evidence capable of reshaping the history already written. A bird list can look like a column of names until the numbers are placed against a map. In the Darién, roughly 670 bird species have been recorded, with some databases listing more than 700. The entire continental United States, an area of about 3.8 million square miles, holds roughly 900 recorded bird species. The Darién approaches that diversity within territory comparable in area to Connecticut, turning a familiar statistic into something easier to imagine. Among those birds are species whose entire known ranges are confined to the Choco and Darien region. The Baudo, Oropendola, Choco tinamu, and Plumbeous forest falcon belong to a group for which the forest is more than one stop along a continental range. Their survival depends on this particular landscape. If one of these species disappeared completely, there would be no distant population waiting elsewhere to restore it. A local loss could therefore become a global extinction. The map becomes even more interesting at the edges of distribution. South American birds reach their northern limits here, while species associated with Central America extend southward into the same forests. The Darién forms a meeting place where lineages shaped on opposite sides of a continent encounter one another. Every mixed flock, nesting colony, or territorial call carries a trace of that long biological exchange. High above the ground, the pattern becomes especially concentrated. Harpy eagles share the aerial environment with crested eagles, ornate hawk eagles, and many other raptors, each occupying different hunting spaces and prey relationships. Some work through the upper canopy, others use gaps and forest edges, while still others search lower layers. Their coexistence reflects a food web with enough structure to divide the sky into ecological neighborhoods. That diversity also makes the Darién a living record of the Great American Biotic Interchange. The meeting was never a single event, completed in one moment. It unfolded through repeated movements across changing landscapes, with populations expanding, retreating, splitting, and meeting again as climate and geography shifted. The bird count also reveals something about time. The species living here are products of millions of years of movement, isolation, adaptation, and renewed contact. Around 3 million years ago, the land bridge connecting North and South America became a route through which animals expanded into unfamiliar territories. Birds carried those histories in their bodies and ranges, gradually sorting themselves according to climate, elevation, food, nesting sites, and competition. The Darien became one of the places where those histories overlapped most intensely. There is another detail that makes the number especially meaningful. 670 is not a final inventory. Bird surveys continue to reach places that have received limited observation, and additional records can appear as researchers explore different elevations, seasons, river corridors, and interior forests. Some records may involve species already known from the region, while others refine the boundaries of where particular birds live. For a landscape this compact, every addition changes the picture. A new observation can extend a known range, reveal a seasonal movement, or identify a species using habitat that had received little attention. The list, therefore, behaves less like a completed catalog and more like a record still being written. Each bird adds another thread to the living history of two continents meeting in one narrow forested passage, where the legacy of their collision remains visible in wings, songs, nesting places, and migrations. A jaguar moving through Central America carries more than its own survival with it. Its movements belong to a much larger biological connection, one that links populations across the length of the American tropics. The Darien is the narrow terrestrial passage where animals can still move between the two continents without crossing an ocean. For species dependent on continuous forest, there is no comparable substitute. Air and water cannot replace the ecological function of a land passage for animals that need forest beneath their feet. Consider the jaguar. Individuals occupying forests in Central America remain connected through the Darien to populations farther south. That connection allows animals to move between populations and exchange genes. When forests become divided into isolated patches, movement becomes harder, encounters become rarer, and genetic exchange gradually declines. The consequences can accumulate through generations, affecting reproductive health, resistance to disease, and the ability of populations to respond to changing conditions. The same principle applies to Baird's tapir, the largest land mammal in Central America. These animals need extensive habitat and access to connected forest for feeding, resting, and movement. The Darien remains one of the most important strongholds for the species. A road, settlement, or cleared strip can appear small on a map while becoming significant to an animal whose life depends on crossing large stretches of intact habitat. White-lipped peccaries reveal another layer of the connection. They travel in social herds and can move across the Panama and Colombia border as they search for food. Along those journeys, seeds pass through the landscape with them. Some seeds germinate far from the parent plant, helping vegetation recolonize disturbed ground and maintaining the movement of plant populations. Their paths can also connect patches of vegetation, allowing forests to retain a wider exchange of plant material. Break the route, and the animals lose access to portions of their range. Plants lose one of their traveling partners as well. The effects extend beyond animals and plants. Tropical forests move water from soil into the atmosphere through transpiration, the release of water vapor from leaves. That moisture contributes to regional rainfall and interacts with winds, clouds, rivers, and surrounding vegetation. A connected forest, therefore, participates in a larger water cycle that reaches beyond the boundary of the Darién itself. Fragmentation can alter these processes, potentially affecting rainfall patterns across Panama and Colombia and influencing ecosystems and agriculture far from the original clearing. The forest therefore participates in atmospheric circulation as well as terrestrial movement, tying animals and vegetation to processes beyond the trees themselves. This is why a corridor can matter even when its area seems modest beside the scale of a continent. A corridor is measured through movement, not merely through square miles of vegetation. It gives animals room to disperse, plants opportunities to spread, and populations a chance to remain connected across generations. Around 3 million years ago, the land bridge linking North and South America created one of the greatest exchanges of terrestrial life in Earth's history. The legacy of that connection remains alive in every animal that crosses the forest, every seed carried into new ground, and every population that remains genetically connected across the isthmus. If the Darién were severed, the immediate change might appear as a line on a map. Its deeper consequence would unfold through generations, as a biological connection built over millions of years gradually ceased to function. The Amazon and the Darién belong to the same tropical world, yet the experience of moving through them can be profoundly different. The Amazon basin covers roughly 7 million square kilometers, which is about 2.7 million square miles, making it the largest tropical rainforest system on Earth. Its scale is difficult to comprehend. Waterways extend for thousands of miles, settlements are scattered throughout the region, and many routes have been used for generations. Danger exists there, sometimes intensely, but distance also creates choices. That distinction matters when danger is measured through exposure. A forest can contain jaguars, venomous snakes, disease-carrying insects, unstable rivers, and difficult terrain without presenting all of those hazards to one traveler at the same moment. Across the Amazon, movement often follows rivers, roads, established trails, or inhabited areas. Medical facilities exist in many regional centers, and experienced local communities provide knowledge of particular landscapes. A traveler may encounter a dangerous place and still have another route available. The Darién compresses those possibilities. There is no established road crossing through the interior, no continuous network of developed settlements, and no medical system distributed along a route. River crossings can become dangerous when rainfall raises water levels, while steep ground, mud, heat, insects, disease, and exhaustion accumulate within the same journey. The problem is therefore less about one extraordinary hazard than the limited ability to step away from several hazards at once. This concentration becomes especially important because the crossing is relatively narrow compared with the Amazon. A person traveling through the Darien cannot spend days following a broad, navigable river toward a safer settlement and still remain on the same overland passage. The terrain itself determines where movement can occur. When one route becomes impassable, alternatives may involve another river, another slope, or another section of forest carrying its own risks. Human movement provides a sobering measure of how exposed people can become. In 2023, more than 520,000 people entered Panama through the Darién province, according to migration monitoring records. The International Organization for Migration documented dozens of deaths and disappearances on the route that year, while authorities and humanitarian organizations have repeatedly warned that the true number is difficult to establish because many bodies are never recovered. Earlier years produced higher documented totals in some datasets, illustrating how incomplete the record can be. None of this makes the Amazon less dangerous. Its enormous area contains hazards on a scale the Darien cannot match, along with environments where isolation can last for days or weeks. The distinction lies in how those hazards are arranged around a traveler. The Amazon offers a greater number of possible landscapes, routes, settlements, and escape options. The Darien concentrates environmental difficulty inside a confined corridor where choices become fewer as the journey continues. That is the precise difference. Size describes how much danger exists. Concentration describes how many forms of danger can surround a person at once and how difficult it may be to avoid them. The Amazon is larger beyond comparison. The Darien is smaller, but its hazards gather into a tighter human passage, where terrain, weather, biology, and isolation can overlap within the same crossing. Late April brings a change that can be measured first in water. Across the Darien, rivers begin responding to the returning rains, their channels filling faster than the surrounding forest can absorb the downpour. A stream that seemed manageable during the dry months can become several meters higher, which is about 10 feet within a short period. At greater rises, water can climb 6 meters, which is about 20 feet above its seasonal low level. The current gathers branches, stones, and soil released from slopes above, turning familiar crossings into moving boundaries. Rainfall in the mountains also travels farther than the eye can follow. A storm can break 32 kilometers upstream, which is about 20 miles away, while the valley below remains sheltered by the canopy. Then water begins moving through tributaries and narrow channels, gathering speed as it descends. A flood may arrive before the distant storm becomes visible, carrying material from places that cannot be seen from the crossing. The river becomes a record of rainfall occurring somewhere beyond the horizon. By the middle of the wet season, the ground has taken in as much water as its structure can hold. Clay-rich soils become heavy and unstable, while exposed roots and slopes lose their grip. Rain that once disappeared into the earth increasingly travels across its surface, finding hollows and depressions that were dry only days earlier. Temporary streams appear, cut across trails, and disappear again when the water recedes. Their paths can shift from one rainfall event to the next. Along the ridgelines, another transformation takes place. Saturated soil adds weight to slopes already shaped by intense tropical weathering. When layers begin to slide, trees, rocks, and mud can move together downslope. The danger is especially significant because higher ground may offer the only practical route around flooded valleys. A ridge, therefore, becomes both refuge from rising water and a landscape capable of sudden collapse. Above all of this, The canopy changes the geometry of movement. Leaves, branches, vines, and fresh growth overlap until the forest roof becomes difficult to penetrate visually. Satellite navigation signals can weaken beneath dense vegetation, especially when moisture and foliage combine to obstruct reception. A device may show a position, yet the surrounding terrain still offers few reliable visual landmarks. Direction becomes dependent on knowledge carried in memory, experience, and the landscape itself. At ground level, rain reshapes the meaning of a path. Mud records footsteps for a moment, then absorbs them beneath fresh water and sediment. Fallen branches create new obstacles. Small channels widen, while larger ones migrate across low ground. A route can remain recognizable in the morning and become impassable by afternoon. Nothing dramatic needs to announce the change. Water accumulates, soil loosens, vegetation bends, and the terrain adjusts. The wet season, therefore, changes more than the amount of rain falling over the Darién. It changes the arrangement of the forest itself. Water redraws channels, slopes shed their surface, trails dissolve into mud, and vegetation closes spaces that had been open weeks earlier. The landscape remains continuous, yet its usable paths are temporary, shaped from one rainfall to the next. The forest continually redirects it. A death in the Darien can leave almost no trace. A river can carry a body beyond the place where anyone saw it disappear, while rain, mud, and vegetation alter the ground around a person who never reaches the next settlement. This makes the recorded number of deaths fundamentally different from the number of lives actually lost. In 2023, 520,085 people were recorded crossing or attempting to cross the Darién Gap. The International Organization for Migration documented 141 known deaths that year. That figure is treated as a minimum because the system depends on deaths being discovered, reported, identified, and connected to the crossing. Each step can fail in terrain where access itself is difficult. Some disappearances begin at water. A person swept away during a flood may be carried downstream into another channel, while search teams face unstable banks and changing currents. Elsewhere, someone may collapse far from a route accessible to rescuers. A serious injury can become fatal when medical treatment is several days away. Illness presents another problem. A person who becomes sick during the crossing and dies after reaching safety may never appear in a data set designed to count deaths during the journey. The missing evidence is therefore part of the geography. Human remains can be covered by sediment, carried by water, or obscured by vegetation. Trails shift with rainfall, and places that were accessible during one season can become difficult to reach during another. The forest does not preserve a clean boundary between an event and its record. It changes both at once. The experience reported by families gives another measure of the danger. Research published from monitoring in 2024 found that 98% of people traveling with children in their care reported that those children faced risks in the Darien. Injuries, illness, and death were among the principal dangers they perceived. This figure comes from people who had actually entered the route, carrying children through conditions that could extend the crossing and increase exposure to exhaustion, dehydration, and hunger. The people making this journey have also come from many different places. In 2023, Venezuelans formed the largest group, followed by Ecuadorians and Haitians, alongside people from many other countries. Their presence reveals something beyond migration statistics. A person does not enter such terrain because the path is easy. The decision reflects pressures elsewhere that can make a dangerous journey appear preferable to remaining where safety, opportunity, or family security have become difficult to find. That is why the death toll remains an incomplete measure. The number 141 tells us that at least that many lives were lost and documented in 1 year. It cannot tell us how many names were never attached to a body, how many disappearances remained unresolved, or how many deaths occurred beyond the boundaries of the official count. For 500 years, the Darién has challenged attempts to map, cross, and fully document its interior. The same physical conditions that complicate movement also complicate remembrance. A death can occur there without leaving the kind of evidence that an accounting system requires. What remains is a number that can be verified, surrounded by an unknown space where the missing lives are still part of the story. Pressure is no longer confined to one purpose or one season. Pressure has begun to arrive from several directions at once, changing the northern edge of the Darién in ways that can be traced from above and felt on the ground. During 2023, more than 500,000 people crossed or attempted to cross the region. Hundreds of thousands of footsteps entered vegetation without established routes, producing trails where there had been none, gathering around rivers and camps, and leaving behind discarded clothing, containers, food packaging, and other material. The movement itself creates a new geography. Paths widen when thousands of people follow the same line. Vegetation is cut back to make passage easier, and temporary camps become points of repeated disturbance. Satellite imagery can detect some of these changes along the northern margin, where concentrated human movement has created patterns of fragmentation. Each individual passage may seem small against the scale of the forest. Repeated across hundreds of thousands of crossings, those small disturbances become a landscape process. A second pressure comes through the organization of movement. The Gulf Clan, a Colombian criminal organization, controls important portions of the migration route and has been reported to charge migrants for passage. Fees commonly range from 100 to 500 United States dollars per person. At that scale, the forest becomes part of an economic system in which routes have value. Keeping people moving along particular corridors can involve clearing vegetation, marking paths, establishing camps, and maintaining access through terrain that otherwise resists regular travel. Farther south, another form of pressure has persisted for decades. Drug trafficking networks have used remote parts of the Darién as logistics corridors, taking advantage of difficult access and limited enforcement. Roads and permanent settlements may be absent, yet temporary routes can still be carved through the forest. Illegal logging, wildlife poaching, land clearing, and the creation of small airstrips can leave scattered disturbances that extend beyond the immediate purpose for which they were made. Protection exists on paper as well as in law. Darién National Park holds designation as a United Nations educational, scientific, and cultural organization World Heritage Site, recognizing the importance of its ecosystems. The designation cannot remove the physical barriers faced by the people responsible for enforcing it. Rangers working with limited access cannot patrol every ridge, river valley, and forest margin. Aircraft and vehicles also face practical limits in terrain where weather, vegetation, and distance complicate regular operations. The clearest signs of pressure appear along the boundaries. Forest loss and fragmentation are most visible where protected habitat meets roads, settlements, migration routes, or other forms of human activity. The deeper interior remains considerably less disturbed, creating an uneven pattern in which the outer forest absorbs much of the pressure while the core retains greater continuity. This changes the meaning of protection. A forest can remain largely intact at its center, while the connections around that center become thinner. Those outer connections matter Because animals move through them, seeds travel across them, and water systems depend on continuous vegetation. The Darien is therefore experiencing several pressures at once: migration, organized crime, resource extraction, and expanding disturbance along its margins. The forest has endured centuries of intrusion in scattered forms. What distinguishes the present moment is the convergence of those pressures across the same living landscape. The Darien can be read in another way, as a living instrument recording changes that arrive from beyond its borders. Its rivers respond to rainfall, its vegetation responds to temperature and moisture, and its animals respond to shifts in the timing and availability of food. Each response belongs to the forest itself, yet together they form a kind of biological record of the atmosphere passing overhead. That record reaches into ocean history. Around 2.8 million years ago, the Isthmus of Panama had become a substantial land bridge, closing the marine connection between the Pacific and Atlantic Oceans. The reorganization of ocean circulation that followed helped establish the conditions associated with the modern Atlantic circulation system, including the Gulf Stream. The consequences extended far beyond Central America, influencing heat transport through the North Atlantic and becoming part of the climate history surrounding Northern Hemisphere glaciation. That connection matters today because the same circulation system is responding to a different world. The Atlantic meridional overturning circulation, the larger system that includes the Gulf Stream, carries heat northward through the Atlantic and returns colder water at depth. Observations and modeling indicate that its behavior has changed over recent decades, although the precise long-term trend remains an active area of research. Studies have identified weakening signals, while direct measurements also show periods of resilience and temporary interruption of that decline. Freshwater entering the North Atlantic is one important part of the story. Melting ice in Greenland adds fresh water to the ocean, while warming changes evaporation, precipitation, and the distribution of salt. Because seawater density helps drive deep circulation, changes in temperature and salinity can alter how efficiently water sinks and moves through the Atlantic. The chain reaches from polar ice to tropical oceans, linking places separated by thousands of miles. The Darien occupies one small portion of that planetary system, yet its own climate is changing as well. Rainfall patterns vary across years. Extreme precipitation can produce damaging floods, and warming temperatures alter the conditions experienced by plants, animals, soils, and rivers. Recent observations in Panama also show how strongly tropical ecosystems can respond when ocean and atmospheric patterns shift, with unusually warm conditions and altered rainfall affecting wildlife and food webs. A forest can therefore serve as a sensor without having any instrument installed within it. Trees record moisture through growth and survival. Rivers register rainfall through their changing flow. Birds and mammals respond when seasonal resources move or become less predictable. Even the composition of vegetation can shift when temperature and water availability change together. None of these signals tells the entire story alone, yet together they can reveal that the surrounding climate system is moving. The human contribution to this newer change is also measurable. Industrial activity has increased atmospheric greenhouse gases for more than 2 centuries, adding persistent forcing to natural climate rhythms. The forest does not separate those influences into neat categories. It receives warmer air, altered rainfall, changing ocean conditions, and shifts in seasonal timing as parts of one connected system. The irony is written into the landscape itself. A land bridge formed through geological change helped reshape ocean circulation on a planetary scale, and the forest that developed across that bridge now receives the consequences of another planetary transformation. The Darien remains difficult to reach, but distance offers no shield from atmospheric change. Its rivers, forests, and living communities are already part of the measurement. At this exact moment, the Darien is carrying on with thousands of processes that never pause for observation. Somewhere above the canopy, a harpy eagle is searching through a territory that may stretch across many square miles. Its movements follow the distribution of prey, the shape of the forest, and the pathways formed by generations of birds that use the same living landscape. Rarity has no meaning to the eagle. Neither does the distant road network ending at the forest edge. There is only the immediate task of finding food and moving through a three-dimensional world of branches, gaps, and air. Far below, water is changing the shape of the ground. A storm moving across higher country can send a river upward within hours, turning a crossing that seemed possible earlier into a moving channel. 4 feet of additional water is enough to erase a familiar route, carry branches downstream, and rearrange stones along the bank. 30 miles away, rainfall can already be altering conditions for people who have not yet heard the storm. The forest receives these changes as part of its ordinary rhythm. Floodwater rises, spreads, withdraws, and leaves behind a different arrangement of mud, leaves, and sediment. On the forest floor, a fer-de-lance may rest among roots and fallen leaves, its patterned scales blending with the colors and textures surrounding it. Its existence carries the accumulated effect of natural selection acting across millions of years. Venom, camouflage, body shape, hunting behavior, and sensitivity to movement are connected pieces of one evolutionary history. Nothing about that history requires an observer. The snake does not need to understand the forest in order to participate in it. Elsewhere, a plant may be manufacturing a chemical compound that has never entered a laboratory record. Its chemistry could influence an insect that feeds upon its leaves, and the presence or absence of that insect could affect pollination, herbivory, or the movement of seeds. Those effects can pass from one organism to another through ordinary acts that appear almost too small to notice. A bite, a flower visited, a fruit carried away, a seed deposited in another patch of soil. Across decades, such interactions can influence which plants establish themselves and which forests develop in particular places. A jaguar may also be moving through the vegetation, following scent along a route shaped by prey, water, cover, and inherited behavior. Its passage connects populations across a landscape that once allowed animals to move between two continental faunas. The jaguar has no concept of genetic exchange. Yet every successful movement between connected populations can contribute to the continued flow of genes. A single animal, therefore, becomes part of a process extending across thousands of miles. This is the present tense of the Darien. It is not an archive waiting for someone to open it. It is an active system, producing interactions every second, whether researchers record them or not. Birds hunt, rivers rearrange channels, snakes sense movement, insects feed, plants defend themselves, seeds travel, and mammals cross invisible boundaries. 3 million years of geological and biological history remain active in these ordinary events. The forest does not pause for science. It continues to generate the evidence that science is still learning how to read, moment after moment, across every layer of its living structure. 5 centuries leave behind a long trail of abandoned intentions. Spanish soldiers entered the Darien, carrying weapons, maps, religious symbols, and the administrative confidence of an expanding empire. Gold was found in the Cana region. Forts appeared along strategic routes. Missionaries followed, roads were imagined. Each effort introduced another layer of human organization into a landscape whose own relationships had been developing for far longer. The structures faded, the records survived, and the forest continued occupying the ground around them. Scotland arrived with a different ambition. Its Darien settlement was supported by national resources and commercial hope, yet the expedition ended in disease, hunger, financial ruin, and abandonment. Centuries later, engineers returned with surveys and proposed routes through the same terrain. Money was allocated, plans were drawn, and machines were considered. The obstacles changed with technology, while the underlying landscape retained its ability to make sustained intervention extraordinarily difficult. Other forces have entered the forest since then. Criminal networks established routes through portions of the region. Large migration movements have created paths where none were intended to exist. Logging and land clearing have pressed against its margins. A changing climate is altering rainfall and flooding patterns. Each pressure arrives with different tools, motives, and timescales. The forest receives them all within the same interconnected system of soil, water, plants, animals, and weather. Its persistence becomes clearer when the idea of resistance is examined closely. The Darien has never formed an absolute barrier. People have crossed it for generations. The Embera and Kuna have traveled through its landscapes. Migrants continue to cross portions of it. Animals move through corridors that human travelers may struggle to follow. Passage is possible. What remains extraordinarily difficult is imposing a lasting external order across the entire ecosystem. That distinction matters. A wall resists by preventing movement. The Darien resists control through the sheer number of relationships that must remain aligned for control to succeed. A road requires stable ground. A settlement requires reliable supplies. A route requires predictable conditions. A permanent network requires maintenance. Every intervention, therefore, depends upon many other conditions continuing to cooperate, while rainfall, rivers, vegetation, disease, wildlife, and terrain continue following their own patterns. Science can measure fragments of this persistence. Researchers can count species, monitor forest cover, record rainfall, track animals, and map changes at the edges. Those measurements are precise within their purpose, yet they cannot fully express the continuity of a living system that has absorbed 5 centuries of pressure without becoming an artifact of the pressures placed upon it. The deeper pattern is found in what remains after each attempt has passed. Forts become ruins. Financial ventures become history. Survey lines disappear beneath vegetation. Routes shift. Political powers change. Economic systems rise and decline. Human intentions leave traces, while the ecological relationships continue operating according to their own requirements. The Darien therefore offers a rare record of persistence without permanence being imposed from above. It has endured through adaptation, connection, reproduction, migration, decomposition, and renewal. Its strength is distributed across countless organisms and processes rather than concentrated in any single defense. That is why the forest can absorb centuries of disruption and still remain recognizably itself. The test has never been whether people can enter. They can. The deeper measure is whether they can make the entire system conform to their design. 5 centuries have provided a long answer. For much of the Darien, the map is more complete than the knowledge beneath it. Aerial surveys can trace the canopy. Boats can follow certain rivers. Researchers can work from accessible boundaries and establish what grows, moves, and changes within reach. The deeper interior remains a different kind of scientific territory, one that resists routine observation, where the forest floor is difficult to observe, and repeated sampling becomes an expedition rather than routine fieldwork. That distinction matters most at ground level. A canopy image can reveal whether trees cover a hillside, yet it cannot identify every fungus threading through fallen wood, every microorganism inhabiting the soil, or every chemical exchange taking place around roots. Those organisms form lower layers of the food web, decomposing material and returning nutrients to plants. Each interaction becomes part of the machinery supporting larger animals, even when the organisms themselves remain unnamed. The biological unknowns extend into disease ecology. Wildlife carries parasites, bacteria, viruses, and other organisms that have evolved within particular communities. Some may already be familiar to science. Others may never have been collected, described, or tested. That uncertainty does not mean an undiscovered disease is waiting to emerge. It means the range of biological relationships inside the forest is wider than available observations can presently describe. The same gap appears in chemistry. Tropical plants have repeatedly provided compounds that became useful in medicine, agriculture, and other fields. Yet chemical diversity cannot be understood from a few collected specimens. A plant growing several valleys away may produce different compounds in response to soil, neighboring species, insects, or microbes around its roots. Each variation adds another piece to a chemical library that has barely been opened, with much of its possible diversity still beyond direct study. Archaeology offers a clear example of what happens when sustained investigation reaches farther inward. The Darién Profundo research, conducted in 2019, examined archaeological evidence in a region whose human history had long been difficult to reconstruct in detail. Findings from such work can alter assumptions about movement, settlement, and connections between communities. One carefully studied landscape can change the story written for an entire region. Biology, ecology, archaeology, and pharmacology all encounter the same boundary. Their methods differ, their questions differ, and their instruments differ, yet each depends upon access to places that can be repeatedly observed. A forest permitting only scattered observations leaves large portions of its biological record outside the sample. What appears rare may simply be difficult to reach. What appears absent may exist farther inside. What seems familiar at the margin may take another form deeper within. There is a deeper tension in that uncertainty. Scientific exploration usually expands as technology improves, while the Darien's accessible margins are being altered by roads, migration routes, extraction, and other pressures. The places easiest to study are changing first. The places least studied may be changing before researchers can establish their original condition. That makes the frontier unusually fragile. Knowledge can be gathered from surviving fragments, but fragments cannot fully recreate a living system after its relationships have been broken. The Darién therefore holds a rare position in modern science, a place where significant discoveries may still lie inside a forest that has never been comprehensively sampled, while the opportunity to understand it is becoming smaller with every alteration at its edges. There is a certain human habit in the word wild. It often describes a place by subtraction, a landscape defined by what people have not built, measured, fenced, or arranged. Applied to the Darién, that description begins to lose its meaning. The forest is not an absence of human order. It is a presence of another order, one that existed before roads, borders, maps, and institutions gave landscapes names. For the Embera and Wunan, the forest is home. Their relationship with it does not depend upon turning every river into a route or every clearing into a permanent structure. Knowledge can exist without ownership. Movement can follow seasons, water, animals, and familiar places without requiring the landscape to conform to an outside plan. The difference is subtle, yet it changes the meaning of the word wild. A place cannot be understood solely through the things outsiders have failed to build there. Ecology offers an even deeper distinction. A functioning forest contains layers of connection that are easy to overlook when land is viewed as scenery. Plants depend upon pollinators. Fruits feed animals that carry seeds away from their parent trees. Predators influence where herbivores feed. Fungi and microorganisms return nutrients to the soil. Water moves through roots, leaves, streams, and atmosphere in linked cycles. Wildness, in this sense, is less about danger than continuity. It describes a system whose relationships remain joined. That completeness also explains why the Darien can seem so resistant to human control. Removing one part of an ecosystem does not produce an isolated change. A missing predator can alter animal behavior. Fewer seed dispersers can change which trees regenerate. A damaged stream can affect soil, vegetation, insects, and animals far beyond the original disturbance. The forest carries its own consequences through connections that no single human project can fully supervise. Conservation policy has become important in protecting what remains. Yet the history of the Darien shows that its persistence began before modern protection existed. The forest survived centuries of expeditions, commercial ventures, military ambitions, migration, extraction, and criminal activity through the strength of its internal relationships. Protection can help preserve those relationships now. It did not create them. Seen this way, wildness becomes almost the opposite of emptiness. A forest is wild when it contains enough of its original relationships for the system to regulate itself across generations. Its trees, animals, fungi, rivers, soils, and atmospheric exchanges form a living continuity. The complexity comes from connection, not isolation. There is no exact counterpart to the Darien in the known world. It is a relatively narrow land bridge joining two continents while supporting ecological exchanges between them. Its landscape emerged from geological change millions of years ago, and its biological relationships continued developing long after that transformation. Human beings have crossed it, studied parts of it, and altered portions of its margins. Sustained control has remained another matter. The distinction reaches beyond language. Calling the Darien wild can make it sound like unfinished land awaiting civilization. Seeing it as whole changes the picture completely. The forest does not need to become more organized. It already possesses an organization of extraordinary depth, expressed through roots, rivers, predators, seeds, microbes, seasons, and movement. Its wildness is the continuity of that living order, still operating on its own terms together. Every expedition into the Darien carried more than supplies. It carried an idea about what a landscape should allow. Soldiers arrived with orders, engineers with measurements, investors with accounts, and explorers with maps still waiting for names. Each generation brought a different instrument of control, yet the forest received them according to its own conditions. The pattern became visible across centuries. Spanish authorities approached the region with military power and administrative ambition. Forts, missions, mines, and routes represented an attempt to make the landscape legible to an expanding empire. Scotland later brought financial capital and commercial confidence, expecting engineering and determination to overcome distance, terrain, and disease. In the modern era, Machines became more capable, maps became more precise, and satellites could observe the canopy from orbit. The basic intention remained familiar. The forest was treated as an obstacle between one side and another. That assumption shaped the meaning of failure. When an expedition withdrew, the terrain was described as difficult. When a project collapsed, the jungle was blamed for consuming money, time, equipment, and lives. Each explanation focused on the immediate barrier. Fewer accounts considered the deeper possibility that the landscape was functioning exactly as an intact ecosystem functions, according to relationships that cannot be negotiated by a road plan or an administrative decree. The communities that have lived within the Darien offer another way of understanding the same place. The Embera and Wunan developed knowledge through residence, movement, observation, and adaptation. Their survival did not require the forest to become predictable in the way an engineered environment must be predictable. Rivers could determine movement, seasons could shape decisions, and familiarity could replace the need to dominate every surrounding feature. Such knowledge treats complexity as something to inhabit. That distinction reaches beyond human history. A forest is assembled from countless interactions that operate simultaneously. Soil organisms influence nutrients. Plants respond to rainfall and light. Insects pollinate flowers and consume leaves. Birds and mammals transport seeds. Predators alter the behavior and distribution of prey. Water links separate habitats through a shared cycle. None of these processes requires a central authority. Their stability emerges from interaction itself. Human civilization often works differently. Roads require routes to be fixed. Borders require territories to be defined. Industry requires resources to be extracted at planned rates. Administration depends upon information being gathered, categorized, and acted upon. Those methods are extraordinarily effective within systems designed around human needs. The Darien belongs to a system whose structure was formed without them. 5 centuries, therefore, leave behind more than a history of failed crossings. They leave an experiment in the limits of control. The same landscape has encountered armies, financiers, missionaries, engineers, traffickers, migrants, scientists, and machines, while continuing to operate through relationships that precede all of them. Its persistence does not prove that civilization is powerless. It shows that power has boundaries when applied to systems whose complexity exceeds the reach of any single plan. The record still carries an unfinished lesson. A civilization can cross a forest without understanding it, map a canopy without knowing every organism below it, and extract value without comprehending every connection being altered. The Darien has endured long enough to make those distinctions visible. Its history suggests that the deepest challenge was never finding a stronger way through. It was learning to recognize when a living system cannot be reduced to a problem waiting for a solution. A forest does not wait for witnesses. Across the Darien, roots continue drawing water, insects continue carrying pollen, and predators continue tracing paths through vegetation, whether a researcher is present or a camera is recording. The processes are already underway when daylight reaches the canopy, and they continue after the last human footprint has softened under rain. Observation can reveal pieces of this activity, yet the activity itself depends on nothing outside the forest. The system is older than every human account of the region. Rivers have carried sediment toward the coast through countless seasons. Plants have competed for light and nutrients. Animals have adapted to one another through generations of feeding, breeding, avoidance, and pursuit. The first Embera canoe did not begin these processes, nor did the arrival of European explorers. Human history entered a system already in motion, then tried to describe it from the outside. Consider one living moment. A harpy eagle may be crossing the upper canopy, while several layers below, a fer-de-lance follows chemical traces across leaf litter. Somewhere farther away, a jaguar moves through a corridor that connects populations separated by geography but joined through reproduction. In damp soil, fungi break down organic material and return nutrients to plants. A flowering species may be receiving pollen from an animal whose role has never been recorded by science. Each event occupies its own space, yet each belongs to the same network. The deeper fact is that their consequences extend far beyond the moment in which they occur. A seed carried today may influence the composition of a patch of forest decades later. A predator removing one animal can alter feeding pressure on another species. A change in rainfall can affect breeding, flowering, river flow, and the movement of animals across an entire season. The forest therefore exists across several clocks at once, from moments measured in seconds to biological changes unfolding across generations. A storm can rearrange a stream within hours, while the consequences of that change may pass through roots, insects, fish, birds, and mammals for years. Long after the water recedes, its influence can remain. Geology adds another scale. The land beneath the living forest records processes that unfolded across millions of years, while individual organisms occupy brief intervals within that history. Some lineages arrived through exchanges between continents, long after the land bridge formed. Others disappeared. New relationships emerged. Evolution kept adjusting the connections, producing a system whose present form is the accumulated outcome of innumerable changes. Human perception has difficulty holding such a system in full. A person can observe one animal, measure one river, collect one leaf, or sequence material from one organism. Those observations are valuable, yet each is a small window into a structure far larger than the window itself. Even extensive research can reveal patterns without capturing every interaction occurring around them. That leaves the Darién with a rare quality. Its existence does not depend upon being named, photographed, mapped, or understood. The forest does not become more complete when science arrives. Science becomes more informed. The distinction matters because it places human knowledge in its proper scale. We are observers entering a process that began long before observation, and the process continues whether our attention remains there or turns elsewhere. A road can end while a forest continues without interruption. At the northern edge of the Darién, pavement gives way to soil, machinery gives way to footpaths, and the measured line of transportation dissolves into a landscape that has no corresponding boundary. The name suggests an empty space between two connected places. From within the forest, that description becomes difficult to sustain. There is no missing piece in the canopy. A harpy eagle moves through the upper air as it would anywhere within its range. A jaguar follows scent across ground, shaped by roots, fallen leaves, and rain. A fer-de-lance rests where vegetation and soil meet, participating in relationships that existed long before any road reached the continent. Rivers continue toward the sea. Plants exchange pollen. Fungi return nutrients to the soil, and seeds travel through the bodies of animals. Nothing in these processes marks a gap. The word belongs to the human map. It describes the interruption in a highway, the absence of a continuous route, the place where an enormous infrastructure project stops. That perspective is useful for transportation, yet it can conceal something larger. A road sees continuity as a line. An ecosystem experiences continuity as a network. Seen that way, the Darien is not a break between North and South America. It is one of the places where their biological histories remain connected. The land bridge that formed millions of years ago allowed animals and plants to move between continents, reshaping ecosystems on both sides. What later appeared to human travelers as an obstacle became, in biological terms, a bridge. The highway stops for many reasons. Terrain made construction extraordinarily difficult. Rivers shift, slopes collapse, rainfall complicates maintenance, and disease has challenged generations of travelers. Environmental protection and the presence of indigenous communities have also shaped what can be built. Political instability, organized crime, and the enormous cost of sustained construction add further barriers. Each factor matters, yet together they still describe the problem from the perspective of infrastructure. The forest itself requires no road to connect its parts. Its connections are carried through water, roots, pollen, seeds, insects, birds, mammals, and predators. They cross distances without needing bridges or signs. A tree does not require a highway to belong to a forest. A jaguar does not need a marked corridor to recognize another living path. The system maintains its relationships through countless exchanges taking place at once. For centuries, civilizations approached this place expecting passage to become control. The Darien repeatedly demonstrated another possibility. Passage can occur without ownership. Knowledge can expand without completeness. A boundary drawn on a map can describe where a road ends while saying very little about what continues beyond it. That is why the name can feel misleading when the forest is considered on its own terms. There is no gap in the living system. There is only a gap between what exists and what human maps have chosen to connect. Its boundaries belong to human description. Its processes belong to a much older order, one that continues whether anyone names the place or not. Tonight, the road remains unfinished. Rain continues falling somewhere among the trees. Water moves downhill. An animal crosses a path that no survey has recorded. Seeds settle into soil, and another cycle begins. The forest does not need to answer the road. It only continues